All right, so in this section, 3.1.3, what we're going to talk about are the slopes of parallel and perpendicular lines. So go ahead and make sure that you copy down the title for today. And then what I want you to do is I want you to take a look at our first picture, kind of getting us back into the swing of things from our last topic, which was all about reflections, translations, rotations. On your graph paper, go ahead and copy to the best of your ability these images, this image down, and then I want you to describe the relationship between the original and image, right? See if you guys can remember which one is the original and which one is the image based on the word. So go ahead, pause the video right now and think about that. All right, coming back up here, what we probably said is that this is a line of reflection. Okay, all of these are equal distances. This is equal distance. So actually, if you think about it, right, this goes down one and then over two, right? And then if I go down one over two, right, it's the same distance. Here, if I want to get to this line, I can again go down one over two, and then here down one over two, I can get to my line, right? If I go down just one, right, so my maybe 2.5, and then I go over one, I get to that point, and again I can go down. Oh, I went down too far, I should say. I went down a whole one. I meant if I went down half, that would leave me right here, and then I can go over here, and then down a half, and then over. So again, it's equal distance. So everything seems to be the same distances, right? Anytime we can justify it using distances, aka slope, little slope triangles, then we know what it is. So it is reflection. Okay, so a lot of things you're going to do today are going to be on your graph paper. So what I want you to do is we are going to copy down this equation. So y is equal to 3/5 x minus 4. And then what I want you to do is I want you to think about what it means to translate this graph up 5 units. And then you'll write the new equation, which will be easy. Again, we're writing it in the y is equal to mx plus b form. And then this is the most important part. What do you notice between this original equation and its new image? And most importantly, what do we think about our slopes? So go ahead and pause the video now and come back to this problem. Okay, so if we are back on this problem, we should have graphed this line. So I'm going to go ahead and graph this line. Oops, wrong paper. So here is my, move this over a little bit so we can see my equation. So what did I say? I said it's y is equal to 3/5 x minus 4, right? So we can see our graph, -4, and I can go up 3, so this would be 2, and then 3 would be somewhere right about here, and then I can go over 5, so we should be at the point 5 comma -1, if I can get it roughly right there. Pretty close. Anyways, that point does exist on our graph. Okay, so if we were to translate this line up, right, 4 unit, up, what did I say, 5 units, that means that this is going to go all the way up 5 units. So I'm going to go ahead, I'm going to zoom in really fast so we can see this a little bit clearer. Projector mode as well. Bam. Oops, there we go. So here's our 5, so 4. So if I go up 1, 2, 3, 4, and then 5, we should have hit this line right here. So our new equation, right, notice that we're not changing it. We didn't change the direction of this graph. So we still should have had the same slope, but this time we came up with an equation. Right, so y is equal to 3/5 x plus 1. So this takes us back to our problem. So our problem asked, write the equation of a resulting image. That is what we wanted. And then what is the relationship between this one and the new image? So if we notice, right, this red line and this blue line, what do they have in common, right? Excellent. They have the same slope. They have different y-intercepts. So this is a tragic love story in math, right? Parallel lines, they will never meet, right? So sad. Okay, so that's what we should have written down here. So I'll come back over here. So, so how do the slopes compare? So we can say same slopes, and what else can we say? Lines are parallel. This is the symbol for parallel, just aka two lines, right? There are two lines that are coming back up, up and down. So we can kind of say that, right? So the lines are parallel. Again, same slope. Okay, and again, today is all about parallel and perpendicular lines. So let's do this one more time. And this time, what you guys are going to do is you're going to need tracing paper. Okay, and you are going to, we already have this line graphed, and we are going to rotate it clockwise, and you're going to rotate it around the point 0, -4, or aka the y-intercept. Okay, and you're going to write the new equation that results, and again, describe the relationship between this original line that we had and the new line. So again, we're no longer focusing on this line anymore. So if you want to draw this on a new graph, right, that would probably be beneficial, right? So again, I'm focusing on this one. So that means when I'm graphing, and it's hard, I'm not going to be able to write on this, but I'm going to draw a plus symbol right here, right, on this point, -0, -4, and then I want to rotate it clockwise, which means if I draw a point up here, it's going to be down here. So again, be thinking visually where my line's going to be. So go ahead and pause that video right now and see what kind of equation we come up with. All right. If we pause the video and came up with it, this is our brand new equation, right? So through this point, right here, 0, -4, we should have actually seen this. So -5/3 x, and this is still -4. Oh, why didn't it pop up? There we go. Okay, so these two lines are meeting at a very particular point, 0, -4, because that's the point that was on the line. We could have rotated it around any point. We could have rotated around 0, 0. It was just easier to rotate it around your y-intercept to make your lines a little bit easier. All right, so this is the line that we should have gotten. Now, the most important other part to this, oops, where did that go, is right here. So we want to know, describe the relationship between these two lines. So what we should have said is that it actually seems to be perpendicular. Okay, these are actually perpendicular lines. So go ahead and make sure that you write this down. Now, maybe you didn't know that these are perpendicular lines. That's okay. All right, we're going to talk a little bit more about what it means to have perpendicular lines. Parallel lines are a little bit easier to figure out, but the most important thing is that 90 degrees. Okay, so I want you to go ahead and write this down. Perpendicular lines form a right angle, aka 90 degrees. Think about this. This is like your x-axis. This is like your y-axis. So, so the original line and the rotated line in part B are perpendicular because they form a 90-degree angle where they intersect. So we look at the slopes of the original line, rotating the line, and make observations you can about those relationships. So again, the most important piece to copy down would be this piece right here. So maybe this picture and then this little sentence right here. Okay. Now, what I want you to try to do now is kind of come back up to this previous problem. Let's try to rotate it. So try to rotate it around the point 0, 0. You might not come up with an equation of our line, which is fine, but try to graph it and see what happens, right? So again, I want you to rotate it around 0, 0. It's the same point. Okay, I don't know why this keeps coming up. So, but you're going to rotate it around 0, 0, so you'll leave your tracing paper on the graph right here. You'll put a little plus sign, rotate it, see where that red graph kind of crosses, and then draw your line to the best of your ability. Go ahead, pause your video now for that. All right. So if you did this, the most important thing would be actually talking about our slope. So our slope should have actually been the same as the previous problem. It's actually going to still be negative 5/3 x. This one's a little bit harder. So again, it's not going through this point 0, 0. It's being rotated around that point. It's actually going to go through a fraction, and this would be negative 20/3. Okay, so I want you to notice again the point of intersection. This should be a 90-degree angle. So again, if you put your line over here and then the little x-axis right here, you will notice how your line is being rotated. Again, what I'm just focusing on is this information right here. Right, they form a 90-degree angle when you rotate them. Okay. So make sure that you also realize it. Other observations we can make. What else do we notice about our slopes? Right, one of the biggest things is that one of our slopes, so y, let me write it on this paper. So y was equal to 3/5 x minus 4, and then one was y is equal to negative 5/3 x minus 4. The other one was this. Was it minus 20/3, I believe. So here's our original, right? I'm going to put a little O for original, and then over here I'll put a little I for image. Notice that it's still the same numbers, 3 and 5. Notice, though, that the 5 is on the top now, and the 3 is on the bottom. Notice that this is a positive slope, this is a negative slope. So you might start to realize that the slopes are actually opposite reciprocals of each other. Right? Again, that's going to be very important when we talk about perpendicular slides. Opposite reciprocals, we can think of them as one's so always one's positive, one's negative, and you just flip your fractions.